In this video, we begin to talk about multithreading support, which comes directly with JavaFX library. In the running clock example, we had the background thread running forever, and it was the expectation the thread was constantly updating the time display on the screen. We only want that kind of background thread to terminate when the user wants to exit the application, so it does not prevent the user from shutting down the application normally. At the same time, there are many circumstances when you run a background task that you expect to terminate at some point. It may be a computation, a database query, a loading of a file, sometimes reading data from a network connection. The bottom line is you expect this task to finish at some point. It may be a successful completion, or it may time out, or it may fail, but still, all possible outcomes do not change the nature of the background task. You want it to be finite. You are expecting it to complete and terminate. Upon completion, you want to make the results visible on the screen and update your view model. In our next demo, I would like to show you an example of a task that computes prime numbers, and you can find the source code for this lecture in week 1306 primes, a subfolder of the zip file that we have for the demo code. So in this project, we assume that the user wants to compute a set of prime numbers, and so let me demonstrate. So this here is a set of 100 numbers, and it's above 1 with 14 zeros, which is 100 trillion. And we discussed this type of work in our earlier demonstrations regarding multi-threading, but this is actually time-consuming. There is a noticeable delay before the task is complete. You can see that it's running, it's reporting that the background task has started, then it finished, and then our JavaFX application thread handles successful outcome, and we display these numbers on the screen. And although it takes a while to finish the computation, the user interface remains responsive, and I can still work with the rest of the input fields in this form, because the computation is of course delegated to the background thread. So the user interface needs responsiveness, therefore any time-consuming tasks have to be delegated to the background threads to run, and we must also follow the rules of model view controller design pattern, designating user interface and data work to separate the view from the data model tiers. In JavaFX library, we have 3 data types available to support multi-threading. The first type is the worker interface. An object implementing the worker interface is an object which performs some work in one or more background threads. A worker object has methods to check observable states defining a worker object lifecycle. So if we scroll down here to a set of states, the worker state can be ready, which means that it's in its initial state, the task is being created. Then we have the scheduled state, which means that it's scheduled to work. It also has the succeeded state, which means that it's completed successfully. Failed means that some exceptions have occurred. Cancelled means that it was interrupted. You can give work to the worker and then ask what's the state of your worker object, and it will return one of these constants. The second data type that supports multi-threading in JavaFX is called task. So task is an abstract class implementing the worker interface, and it supports things that we want to run in our worker threads, useful for programming asynchronous tasks in JavaFX user interface environment. And there is also another data type, which is called a service class, which is the executor of a task. It is a subclass of a worker thread with the functionality of an executor service in a pool of threads. The service is designed to execute a task. So any task defined by the application can easily be used with a service. As a result, using service to run JavaFX tasks, it's easy and natural way to submit the tasks to run under Java Concurrency Executor API. Since a task object implements runnable interface, you can also call it directly by invoking the run method, but that is not how we're going to do this in JavaFX. In fact, let me show you how we configure and run the task of computing these prime numbers in our demo application.